first we are solving with respect to A, right? So moments about A. Okay. Uh, right. So for the first one is for 70 Newton force, right? I have to calculate with respect to A, distance is given, but I want to calculate the perpendicular distance, right? So you see the concept of perpendicular distance. Perpendicular distance may actually come somewhere here, right? So I actually don't know what is this distance, right? This distance is not known, so I cannot actually directly solve this uh, question, right? This part, the 17 moment cannot be calculated directly because of the same reason where in the perpendicular distance is not known because it is not making 90 degrees with the, the A, right? It is actually making an angle of 135 when it acts on the plane. So now you can see that if it is making 135, it means what is the other angle, right? What is this angle? The angle made by the particular 17 Newton force with respect to the x-axis is 180 minus 135. So this is actually 45 degrees, right? So now, right, I cannot solve this directly. I have to use what you call as, right, I have to resolve this into two components. First component is the one component which acts like vertically downwards and one component which is horizontal, right? The 17 Newton has to be split into these two. Okay, now what is the out of which again you see that the x component is going to pass through A, so there is no moment because x component passes through that. So, right, I can only do the calculate the moment with respect to the y-axis component, right? So, what is the y component of this force, right? So, the y component of this force 17 Newton is 17, right? The angle is given with respect to x-axis, so sine 45. 17 sine 45 is the vertical component. Now you see when I say vertical component, I know the shortest distance. Perpendicular distance is directly given. So the perpendicular distance given is measurable only with respect to the vertical component of the 17 Newton force, and it is not with respect to the horizontal component or the given force as it is. Okay, so 1745, this is the force into the distance. Distance is 1.75 meters. All right, so force into distance, and I need to find out whether this is going to rotate clockwise or anti-clockwise. So I think this is going to rotate it with respect to A. This is going to rotate in, right, from up to down. It is going to rotate in the anti-clockwise direction. So anti-clockwise moment is, right, according to us, it is positive, right? So let us calculate that. So this is a 17 sine 45. 17 sine 45 into 1.75 equal to, yes, 21.036, right? This is Newton meters and it is positive, right? So next answer, we are going to consider the 30 Newton force. So if you look at the 30 Newton force, it is going to pass through the point A itself, right? So the shortest distance becomes equal to how much? 0. It's passing through A. So for 30 Newton, this is 30 into 0 is equal to 0, right? Then we'll move on to the next force, that is how much? 75. So you can see that this 75 Newton makes an angle 45 degree with this. So again, I have the same problem. This is going to pass like this. So the shortest distance comes somewhere else. So I am not able to solve this directly. So I have to split this once again into the horizontal and the vertical component. So out of this, if you see, the horizontal component will be something like this, which passes through the point A. So since it passes through the point A, I don't have the what you call moment, right, of the horizontal component, but vertical component is going to have. So vertical component is 75. Angle is given with respect to x-axis. So 17 sine 45. This is the force into the distance. Distance is 1.08 meters. And I have to consider the sign as well. So since it is moving up to down and this is over here, the force is going to push this downward. So it is actually clockwise. So according to our convention, clockwise becomes negative. All right, so let's make this. So this is negative and minus 57.275 Newton meters. All right, then let's move further. So the next force is 60 Newton. All right, for a 60 Newton force, we will calculate this very similar fashion. We have to calculate this. So this means you can see what is the, it's actually perpendicularly being applied at point B. So you can see that the perpendicular distance between A and B is the straightforward distance which we see here. So the force is 60 into distance will be 1.08 plus 4.35. This is the total distance, and I just have to decide whether it is positive or negative. Force applied B makes that particular rod to move anti-clockwise, right? So if you apply a force at B, something which is present at A, right, as a reference point will move upwards, right? So because of that, this is still positive. Okay, so 60 into 1.08 plus 4.35. So many Newton meters. Okay, then about the 10 Newton. If you look at the 10 Newton, the 10 Newton force is horizontal, which means it is actually passing through the point A, right? It passes through the point and, right, this is horizontal. So 10 into distance is 0, so 0 Newton meters. All right, so this is how you try to calculate the moment about A. Now let's go to the same question, but the moments are supposed to be calculated about B. So let's look at the same question now. So again, B is located here. So if I try to consider the 17 Newton, we don't have a direct solution because the perpendicular distance of this force is somewhere here, right? I don't know what is this distance at any cost. So we cannot find that, right, that easily. So because of that, what we are going to do now, we will try to split this into two parts, horizontal and vertical, out of which horizontal passes through B. You don't have to find that component's moment, right? I just have to find out the one which is vertical. Okay, so first one, the 17 Newton force. The moment is now, the vertical component is 17 sine 45. Okay, into, calculate the distance. Now that you see the distance is now larger distance, right? So distance is 1.75 plus 1.08 plus 4.35. And with respect to B, this force is going to act anti-clockwise, so it is positive. Okay, yeah. 86.309 Newton meters. Yes, right. So next one, I have the force that is 30 Newton. And previously with respect to A, it was 0. But now with respect to B, it is not 0 because it is not passing through B. Okay, so 30 Newton is the next one. For a 30 Newton force, you can calculate the moment by using the same formula, force into distance. And the distance now you are going to write will be uh, to the left, that is 1.08 and 4.35. So 30 Newton is the force into 1.08 plus 4.35. Now I just have to measure whether it is positive or negative. If you look at the given diagram, right, with respect to B, a force that is applied at point A downwards makes this to rotate anti-clockwise, right? So anti-clockwise moment is positive, so this answer is going to be a positive. 162.9 Newton meter is the answer. All right, then we'll move to the next force. That is 75 Newton. 75 Newton is acting downwards, but makes an angle 45. Anyway, we have a solution. We split this into horizontal and vertical, out of which horizontal passes through B, only vertical will be considered. Okay, so this is the next one, 75 Newton. The 75 Newton, if I split it into vertical component, 75 into sine of 45, this is the force, into the distance is 4.35. And if I consider the direction in which this is going to act, this is going to act at downwards. So downwards means it's going to rotate the axis which is present at B in anti-clockwise. So this is also going to be positive. 230.69 Newton meter. Okay, then let's move further. The next force is 60 Newton, and I can see that the 60 Newton is passing through B, so the moment is 0. Okay, so 60 Newton, the moment is 60 into distance being 0, this is 0 Newton meter. Even the 10 Newton which is at the end, that is also passing through the point B. So this is 10 into 0, so 0 Newton meters is the answer. Okay, so the moments can be calculated using this particular concept. Okay, now so let us go to the concept of the resultant of concurrent coplanar forces. So there are two words, right? First word says that it is concurrent. So what you mean by concurrent forces? So when I say the forces are concurrent, right? This means all the forces act on a single point. Okay, then there is another word called as a coplanar. Right, so the forces are said to be coplanar, right, if all forces are present on the same plane. Right, so let me try to represent the coplanar concurrent force system. So if at all I try to, let's say, write, let me assume this is a plane which I'm talking about, and all the forces are acting on the same point, and every force is, right? This is force 1, right? So say this is force number 2. Say this is force number 3. Say this is the force number 4, and maybe I can write another force which is force number 5. Okay, so you can see that all the forces are actually acting on the same point here, and all the forces are present on a given plane F1, F2, F3. So the head of the force is here, so this is F4, and this is actually acting here, so this is F5. All the forces are on the same plane and all are acting on a common point. So such system is called as, I can see the concurrent system here because everything is acting on the same plane, same point, sorry. And coplanar also I can see because all the forces are on the same given plane. If you have a system like this is called as concurrent coplanar, right? Forces. So my idea is first to look at how to calculate the resultant, right? Whenever I have such a system, right, the resultant is going to show you the following properties. Okay, so okay, the resultant R is equal to root of forces along x-axis whole square plus forces along y-axis the whole square. In the sense, you split the given force system, right, into every force has to be splitted into x and y component, fx and fy, right? So take the fx component, take a sum, right? And okay, I'll make a modification in the equation just to make sure that this gives you a clear idea of what exactly we are doing. I'll slightly modify. Okay, so the modification is I don't simply write the fx and fy like this. Instead, I'll write a summation as well. So this is, let me write this. So there is a summation coming into picture. So this is sum of the fx squares and sum of the fy squares. Okay. So, right, I'll make the things very clear when we write the, when we solve a problem, right? I have to take a summation of fx, square it, summation of fy also square it. If you want, you can put a bracket here because square comes outside, right? So summation of fx whole square, summation fy the square whole square. Okay, right. Then there will be what is called as an angle of the resultant. Resultant's magnitude is this, and theta is equal to, simply it is tan inverse of sum of fy divided by sum of the fx. So these are the two equations which we need to consider to solve this kind of problems, where our question is find the resultant of the following system, and they will not mention that whether the system is concurrent coplanar, right, non-concurrent coplanar, etc. Right? The identification we should do. Okay, so first question on this. So only two equations to be used. Find the resultant. Right? So now the question that we are going to write here itself is going to be a concurrent coplanar system. X-axis, y-axis. Let me mark the forces with color. This is 20 Newton. Forty Newton, 18 degrees. 35 Newton, 40 degrees. Newton, 60 degrees. This is 10 Newton. This is 50 Newton, 10 degrees. All right, so we can see that there are 6 forces, and this is in order to show that they are acting on the same plane, they have given the x and y axis. So indicating that this is everything is acting on the same plane, and we have to identify that all the forces pass through the common point at the origin, right? Which indicates that this is a coplanar concurrent force system. So we just have to find the fx, fy for each of the force, right? Calculate the sum of all the fx components, call it as summation fx, right? And take the sum of all the forces y components, call it as a summation fy, right? And use the equations to get the answer. Straightforward way. So let's go to the first part, that I want to calculate the sum of all the forces x component. That is, split every force into x component one by one. So you can see that the 20 Newton is completely along x axis. So this is plus 20. Take care of the sign as well, plus and minus. All right. Next, we'll go for the 40 Newton. The 40 Newton is in the first quadrant. So the x component is positive, right? So this is plus 40. See, the angle is given with respect to y-axis. So it is sine 80. That is the x component. All right. Next, move to the 35 Newton. This is present in the second quadrant. So the force is negative along x-axis. Minus. So this is 35. Angle is given with respect to which one? X-axis. So this is cos 40. Right. Then we'll move on to the 40 Newton, which is present in the third quadrant. Right. So right, we already know how to split the forces into x and y components. So this is going to be, it's in the third quadrant, so negative, minus 40, right? Since the angle is given with respect to y axis, this is sine 60, right? Then you see the 10 Newton is along y axis, no component along x axis, right? So perfectly along y axis means no component along x axis. So you don't have to write that. Then we'll come to the 50 Newton force. So this 50 Newton force is in the fourth quadrant, so x component is positive. So plus 50, angle is given with respect to x axis, so cos 10 degrees. So take this, right, and evaluate this complete equation so that you get the total component along the x axis. So this is equal to 20.148 Newton. All right, let's try to write the summation of Fy, right? All the forces along y-axis, right? So we'll start with the 20 Newton. 20 Newton is completely along x-axis, which means no component along y. You don't have to write. Let's start with the 40 Newton. So it's going upwards, so positive. So this is 40. Angle is given with respect to which axis? With respect to y-axis. So this has to be cos 40, cos 18 degrees. Then the next one is 35 Newton. That is also going upwards. So which means it is positive. Plus 35. Angle needs to be, angle is with respect to x-axis. So this is sine. Okay, sine 40 degrees. Then the 40 Newton is coming downward. So this is minus 40 cos 60 minus 10, and the last force, that is also minus 50 sine 10 degrees. Just a minute, 21.857 Newton. So we got summation Fx, summation Fy. Calculate the resultant. This is the magnitude. Okay, the force has a magnitude that is equal to root of sum of the Fx which we have calculated, it's a square, plus the sum of Fy calculated square. So that has to be under root 20.148 the whole square plus 21.857 square. Yes. So theta comes to be 47.32 degrees. So you see, we can calculate the resultant and theta. So that means I know now the resultant is going to be having an angle of, let me change the color for resultant. This is just to show, right? So there is a resultant that is acting somewhere here, right, whose magnitude is how much? Magnitude is known as 29 point something, okay, 72, and this angle is known to us, right, that is 47.32 degrees. See, this is what is the resultant. Where the resultant of this whole system, can you replace all these forces by a single force? Yes, the answer is you can replace all the six, remove the six forces and replace it by a 29.72 Newton force, making an angle of theta, that is 47.32 Newtons, right, with respect to the x-axis. All right, so that's the first part. Let's solve another question of the same type. So question is, find the resultant, and this is the problem. 80 Newton, 25 degrees. Newton, 70 degrees. Newton, 35 degrees. 110 Newton, 40 degrees. So this is x-axis, this is y-axis. So the answer, magnitude of the resultant, that is R, equals to Newton, okay, and the theta is equal to, no problem, minus how much? 54 degrees. So minus means this is over here. Okay, so this angle is considered as negative. All right, so magnitude is 59.351 and this angle is 29.54, right? This angle, if you measure an angle downwards, that is negative. If you measure angle in this way, that is positive. Okay, so this is the answer for the question. So now we know how to solve a problem to find the resultant of a system of forces which are concurrent and coplanar.